Hello, everyone, and welcome to another session in the F5's MyForum webinar series. For those of you that are new to this platform, MyForum is a virtual learning experience and content hub packed with the latest updates and insight and brought to you from the comfort and safety of your home office. I am Raffaele D'Albenzio, manager of the F5 Solution Engineers for Global Service Providers in EMEA, and I will be your facilitator for today's webinar in a session in our service provider track. Before we get started, just a few housekeeping items to note. You can adjust the size of the presentation box on your console by expanding the corner of the box. If at any time through the presentation you experience connection issues, please try refreshing the console by pressing the F5 button if you are a Windows user, or Command+R if you are a Mac user. If the problem persists, please try closing the event window and relaunching it again. You may find trying an alternative browser fixes the issue. If you have any questions through the presentation, please submit them in the Q&A box. We will have a live Q&A session at the end. In the unfortunate case you cannot attend the whole session, we will be sending out a link to a recording of this presentation afterwards. Today, we have with us Bart Salets, Senior Director of F5 Solution Architects in the EMEA region. Bart will present us the new security challenges in the evolving 5G ecosystems and, due to the nature of 5G architecture, what we can learn from the IT world. Over to you, Bart.
All right, thank you, Raffaele, for the introduction, and welcome everybody joining us today. So I'm sure many of you have been on 5G security webinars before, just like myself, and one of the challenges is always like, what to expect from it, right? Because 5G security is such a broad topic. You can either go very broad and keep it very high level, or you can zoom into a specific thing and go very deep. But it's a very generic thing to talk about. Now, the approach we're going to take today is, as many of you know, F5 is a company that is active both in the telco segment, like we provide solutions for mobile, GI-LAN traffic management. We provide traffic management and security for GTP, diameter, SIP, telco protocols. We have DNS solutions, etc. But at the same time, we're obviously a company with a large history in IT data centers, sitting in front of applications, providing ADC functions, application security, etc. So we can look at this from both angles. And if you look at what 5G is all about, it's all about an architecture that moves more and more into an IT-based architecture. So what I'm going to try and do today is give you a bit of a view on how we look at that evolution and how can the 5G world take some lessons from the IT world in some of its security aspects. Now, I just made a statement, right, saying that 5G is all about telecom operators looking more and more into becoming IT companies. Now, this is not something I'm making up by myself, right? These are actually the two statements you see here are from CTOs, from very large European service providers. And these statements were made at 5G World Virtual Conference just, I think, 2 months ago or so. So it's very recent. So here you can see they both more or less make the same statement, right? They see 5G as a catalyst to not just get into a new technology like we did with previous generations of mobile generations, but it's really a catalyst to completely transform the company, to become more of an IT company versus being a telecom operator, which is what they have always been. So 5G is so much more than just a new generation in mobile technology. It's really a driver to really transform telecom operators, and as you see in the Vodafone statements, it's like they think they will look entirely different company 5 years from now. Now, why is that? Why are they making such statements? Again, if you look at evolution of mobile technology, whether you move from 2G to 3G or 3G to 4G, you had new elements in the network, you had different distributions of functionality. Obviously, you had radio technology, which allowed you to get more bandwidth, etc. But ultimately, the architecture was a telco architecture, right? You had dedicated purpose-built boxes for data plane functions, for control plane functions. Market was completely dominated by telco vendors. And most of the protocols used in that type of architecture were telco protocols. Most of the protocols used in that environment are not used anywhere else in the world. So it was a very specific type of architecture, moving from 2G, 3G to 4G. Now moving to 5G, yes, we again have a different set of elements. We again have a different distribution of functionalities, like you have things like control and user plane separation to make the architecture more scalable. But what is also different here is the architecture, right? Rather than thinking at 5G in terms of, again, a set of dedicated purpose-built boxes interacting with each other with telco protocols, they really designed this architecture to look like a modern application, where just like in a modern application where you have different microservices interacting with each other via an API, now you have these different 5G functions in the 5G core interacting with each other via an API, which actually is HTTP2 based. Again, something we leverage from the IoT industry. So this 5G core architecture doesn't look very different from how modern application architectures look like. And this happens to be an area where F5 has a lot of experience in, right? Because we, on the data center side, we have been dealing with both traditional as well as modern applications for quite some time now. And of course, all of this is going to be deployed on cloud-based architecture. So everything is virtual, everything is containerized. So all these things that movement that started in the IT industry a couple of years ago, we are now starting to see that make significant inroads into 5G core as well. And that's why these CTOs of these large service providers are making these statements, right? In order to build the architecture that you see here on the left-hand side, you don't only need telco experts. You need people with IT knowledge, with knowledge of underlying virtualization architectures, containerization, Kubernetes, etc. Now that's the 5G core architecture. The other interesting evolution is edge computing. And of course, I mean, edge computing and 5G are not necessarily linked with each other. What we typically see is that 5G is driving edge compute strategies, but it doesn't have to, right? You can also build edge compute architectures without 5G, even for wireline networks. But the interesting thing is that some of the use cases that are being enabled or will be enabled by 5G technology will actually require things like low latency processing. For some IoT use cases, you may not want to backhaul all the data that you generate to make heavy computations. You may want to keep that data more closer to the IoT devices generating the data to do local computations. So for these types of use cases, you need to move some of the applications closer to the devices. And that means that instead of keeping your applications very centralized in a private data center or private cloud or even in a public cloud, some of these really need to be brought closer to the end user. And this is what drives edge compute strategies. Now, if you look at the previous picture and you think about, okay, I'm going to deploy a 5G core on a cloud-based architecture, and now you have to start moving your applications deep into the telco network, you could start asking yourself the question, why would I build a different architecture for my network functions compared to my applications which need to be distributed? Why don't I build a common telco cloud, as most service providers call it today, which is one uniform architecture which allows me to host both network functions for the 5G core, as you saw in the previous picture, as well as the applications next to it on that same type of architecture. Because at the end of the day, these modern applications are using the exact same underlying technologies to get hosted anyway. So the key point here is that with edge computing, you actually bring applications, or IT workloads, as we call them, you bring them deep into the telco network. And that presents an opportunity for new business. But I think it also presents an opportunity to harmonize in the long run the architecture that service providers will be building so that they can host both these network functions and applications side by side. So ultimately, this is the picture we're getting to, right? And the journey could be different for different service providers, but I think many of them have this vision of building a telco cloud where you have centralized POPs all the way into far edge locations for mobile edge computing, etc. On top of that, you build a virtualization and a containerization platform. And then on top there, you have a combination of these network functions, and you see a couple of 5G core functions, but this could be virtual RAN functions as well, obviously, as well as the applications. So we're not saying that we're expecting people to run an SMF and an IoT application on the same physical server. I think that's a bit unlikely to happen. But still, you could run them on separate servers, but using the same container infrastructure or the same virtualization infrastructure. So ultimately, the big question now is, and that was the title of the presentation anyway, is like, what can we learn from the IT industry here? Because we are using a lot of IT concepts to ultimately get to this type of architecture. So what can we learn from that environment to bring into the telco business, both for rolling out 5G networks as well as for rolling out edge compute architectures? So the big question that you could ask yourself, if you look at this, you can look at this from two different angles, right? One angle is, I'm starting from a telco environment, and I think about, okay, what do I need to do with the telco security solutions that we have today and that we still believe are very relevant in 5G? How do we adapt them to fit in these new types of modern architectures, leveraging IT and cloud? The other way to look at it is can I leverage some of the existing IT security solutions and potentially add a little bit of telco awareness to them? And both things are valid options to look at. And as you will see in the rest of the presentation, what we need in the industry is actually a little bit of both. And I'll give a couple of examples of how we as a company are looking at this and how we are evolving some of our solutions from one area into the other. Now, in order to make this a little bit more structured, I tried to divide up the different aspects that I want to talk about. And of course, there's different ways of chopping up how to talk about 5G. So this is just my way of looking at it and making this presentation a little bit more digestible. So the way I look at it is that we're going to talk first about the telco workloads, right? So these are the 5G functions that you're going to host on a telco cloud architecture. And I'm dividing it in three blocks. One is the data plane. This is obviously anything related to carrying the data between the end user device and whatever application you're hosting yourself in your edge locations, in your centralized POPs, as well as to the internet. So from the outside here, you are connecting to the public internet, which is introducing some threats, obviously. The next layer is the control and signaling plane. So think about this as anything related with connecting to the network, the authentication, the mobility aspects, the roaming aspects. So here you will typically, or the service provider will typically interconnect with roaming partners, which is another degree of security threats that can come into your network. And then the 5G management plane is really some of the elements that really sit on top of everything, and where you as a service provider may actually open up some APIs to third parties to give them a little bit more access and a little bit more control over your 5G network. So concepts like network slicing, etc., really allow you to chop up your network in different slices, and you may actually want to give some external parties access to some of these slices and give them a little bit more control over them. Again, that obviously gives them a little bit more control over your network, and that introduces security risks as well. At the bottom, you see the application plane. So this is really talking about, what type of applications are you going to host on this architecture, and what do you need to do in terms of managing them and securing them as well. And here, obviously, you will have your own applications that you host in your edge compute sites, but you will most likely also open that up for third parties to host their whatever video applications, whatever virtual reality applications, IoT applications, etc. So that's another ecosystem that you're going to open up to third parties. So in the next couple of slides, I'm going to walk through each of these and explain a little bit how we look at that. Now, first we have the data plane, right? And the data plane is really about, how do you manage user traffic? And as a company, as F5, we've been very successful in helping our customers simplify and consolidate what is called their GI LAN. So this is the part in the network behind the 4GP gateway, where we do all sorts of traffic management and security capabilities. Think carrier grade NAT, GI firewall, TCP optimization, video optimization, deep packet inspection for analytics or for free rating purposes, etc. And this is the perfect example of where we need to evolve an existing physical 3G, 4G solution into a full-blown virtual containerized 5G world. And as a company, that is a process that we started already a couple of years ago, really evolving our physical GI LAN, consolidated GI LAN solution into highly scalable virtual GI LAN solution, providing all these functionalities. And as you can see from a functionality perspective, a lot of the functions are actually very much focused on security. GI firewall, CG NAT is obviously a necessity for most service providers. But we started to see that more and more service providers are adding more sophisticated DDoS protection capabilities to the GI firewall to get a next level of protection. But also with more and more IoT use cases being added to the network, we see IoT firewall requirements popping up. And think of this as a solution where on a per IoT device basis, a PCRF can push a security policy into the GI LAN, really specifying to which locations, to which URLs this particular IoT device is able to talk to, and vice versa. Because the last thing you want is you don't want to have malware getting into your IoT devices. So people need a bit more security for these types of use cases than they typically want for mobile broadband use cases. DNS is another interesting one. Secure DNS cache resolver now with DOH and DOT becoming very popular. That's another area where we are investing in. So from an evolution perspective, the way we look at it is obviously we evolve the functionalities that people need, moving from 4G to, let's say, 5G non-standalone, which means adding 5G radio to this 4G core network. From that perspective, scalability is crucial because we will get a lot more traffic because of the extra bandwidth that is added. So making such a virtual solution scale is super critical. And of course, we need to evolve the functionalities as well. The other thing that we're doing at the moment is we're looking into how can we port some of the capabilities that we used to run in our own purpose-built hardware on dedicated FPGAs. How can we port those functions to SmartNICs? And what that helps us to do is it helps us to reduce the dependency on purpose-built platforms for very specific functions. Let me go into a little bit more detail on that. So if you look at historically, let's take DDoS as an example here. In order to provide DDoS mitigation, people have always been using purpose-built DDoS platforms, and F5 is in that category as well. So we have FPGAs on board, which help us to mitigate against volumetric DDoS attacks. So they actually filter out the bad traffic, the volumetric traffic, before it hits the CPU and before the CPUs need to do their more sophisticated tasks. In the DDoS world, when we speak about CPU-based DDoS mitigation, think about layer 7 application-level DDoS. In the application world, that is typically HTTP. So HTTP is vulnerable to a couple of attacks which really try to maximize the CPU with relatively simple attacks. But in the telco world, think about DNS. The FPGA will help you mitigate a volumetric DNS UDP flood, if you will. and the CPU will help you mitigate against a more sophisticated DDoS attack. Think about DNS random subdomain attacks. Think about DNS tunneling, which is DNS abuse. So that's typically how our customers have been deploying these types of solutions. Now, once you move to virtual environments and now think about applications, let's say we have applications living in a private cloud or a public cloud. What you can do is you can move the layer 7 DDoS capabilities into the CPUs, leveraging virtual editions. But for the volumetric DDoS mitigation, you still need purpose-built hardware in order to make it scale. And therefore, most of our customers still have a couple of purpose-built DDoS platforms sitting in front of these virtualized infrastructures, because it's the only way that was capable of protecting your virtual infrastructure from volumetric attacks. What we're doing now is we're actually porting some of our capabilities into a SmartNIC, and we started working together with Intel on this. So Intel has a PAC 3000 SmartNIC, and we developed code that allows our VE to program their SmartNIC to provide us with that volumetric DDoS mitigation. And what the beauty of this is that it really allows our customers to reduce their dependency on purpose-built platforms. And if you think about the evolution to edge computing is very distributed, and you may not always have a lot of physical space to put equipment in there. So by just preventing you to deploy a purpose-built platform and have that functionality in the SmartNIC, you save a lot on space as well, and you reduce the amount of different hardware components that you need to build the architecture. For people who are interested in learning more details about this, there is actually a MyForum session tomorrow, where we will be co-presenting with Intel this solution into a little bit more detail, and the guys will also show you a demo. So if you're interested, we welcome you all tomorrow on another MyForum session. So that was a good example of how you evolve a telco solution into a new environment by virtualizing it, by introducing SmartNIC, and ultimately also containerizing those solutions. The control plane, and before I get into the control plane, let me take a step back and explain you a little bit how an application in a microservices environment looks like, and then show you how similar this 5G environment is. So I'll try to keep it high level here, but at least I want everybody to understand the concept. So if you take a modern application, and in this example, it's a modern application which is built out of 3 microservices, and each of these microservices, they live in their own pod, and there is an application container in that pod. So these 3 microservices could have been developed by different teams because it's different functions of the application, and they obviously agree on what type of APIs you have between them to get interaction, and as a whole, they deliver the functionality of the application. So the orange thing is a pod in a container environment, and everything lives in a Kubernetes environment in that application cluster. Now, there's a couple of things that you typically need. First, you want to expose this application to the outside world. So deploying the application containers within a Kubernetes cluster doesn't necessarily make them available to the outside world. And that's where the concept of a Kubernetes ingress object plays an important role. What is Kubernetes ingress? It provides access to the outside world. It provides a reverse proxy function, so that that reverse proxy takes traffic from the user, from the outside world, and load balance it or routes it to the right application container in the backend. But what we also have been doing over the last 2-3 years is we've been adding more and more capabilities to ensure that our customers can also enable security functions at that ingress point. Because making the application available is one thing. Obviously, you want to have this in a very secure fashion, right? You want to have web application firewall control. You may want to have anti-DDoS control. For some applications, you may need access, identity and access management, access control. So we've extended our solutions to make sure that in this IT environment, you can actually configure traffic routing policies and security policies at that Kubernetes ingress point. Now that's on the left-hand side, the user interaction. On the right-hand side, some applications might have APIs to interconnect with business partners. If I just take an example, Google Maps. If you go to Google Maps, you're sitting on the left-hand side and you're interacting with the Google Maps application via your web browser or your mobile app or whatever, right? But you have other companies like Uber. They're using the Google APIs to actually get their navigation capabilities. So they're interconnecting with the Google platform on the right-hand side. And for that, you don't use Kubernetes Ingress. You typically use an API gateway, as it is called. This is the area of API management and API gateway. So you publish an API, which is where you specify how the API looks like, so your business partners know exactly what fields to use, what JSON objects to use to interact with you. But obviously, there is also an important element of security here, both in terms of access control, as well in terms of avoiding the REST API getting abused for whatever purposes by whoever hackers are out there. So that is the business of API gateways. And then internally, you see that thing called service mesh. Now, in a 3-pod application, you may not really need a service mesh, but some applications are very complex and have a lot of microservices that need to interact with each other. And some of these microservices may sit in other nodes, which means they need to traverse a network. So in order to get security within the environment, people are using service mesh. The service mesh is for two main purposes, I would say. One is that security aspect. So you provide mutual TLS authentication between the different pods. And the second aspect is to get full observability. So you get visibility into the traffic flows between the different microservices running in your application. So you get a little bit of a view of where the bottlenecks could be, where performance challenges could be, etc. So service mesh is really something to manage applications internally. And service meshes are typically decoupled from the application. So that's why it's you see that there is a different proxy injected into these Kubernetes pods to make it happen. But I'm not going to go into further detail on this. The key point here is that you can see that in each of these 3 elements, you have some degree of security for a modern application. Now, if I translate this same picture into this 5G core service-based architecture, right? Now the application container is actually a 5G core function. It could be an SMF, an AMF, an NRF, you name it. And if we now have a look at like, okay, what do we need? So on the left-hand side, we're obviously not connecting to users, right? I mean, users are not using their web browser to talk to an SMF, an NRF, an AMF. That's not really the point here. But this system will interconnect with other systems. And these could be legacy 4G nodes. It could be other 5G nodes that are part of a different environment. And as you can see, they speak HTTP2, which is similar to what you saw on the previous slide. But it's given there's 4G elements there, you may have diameter traffic there as well, or you could have GTP traffic, depending on what type of 5G core functions you have in that Kubernetes cluster, right? So the thing here is that in order for a Kubernetes ingress to become a little bit more telco aware, you will need to add new protocols, which most solutions on the market providing Kubernetes ingress do not support today, which is diameter and security. And you might need some interworking functions on that entry point into your 5G core service-based architecture. If we now move to the right-hand side, so here where the business partner here is actually the roaming partner. So you're connecting with the IPX, you connect with the roaming partners. And the SEPP, the Security Edge Protection Proxy, is actually an API gateway, if you will, for the 5G core service-based architecture. So the SEPP is defined by 3GPP, right? So that's a very well-defined element. And it leverages a lot of the functions that you would find in traditional API gateways. But also here, 3GPP specified a couple of additional points, like there is JSON object signing, which is encrypting objects within the JSON payload for specific security purposes. But again, this is a perfect example of how you can actually augment an IT-based API management solution and make it a bit more telco aware. The element on the right, the telco ingress, that is not really an element that is defined by 3GPP. That is actually really an infrastructure component that helps you to connect your internal 5G functions with the external world. And then within the service-based architecture, you could have an SMF from vendor A interacting with an AMF from vendor B. So if you go for a fully open architecture, which is what we believe ultimately the industry will want, you may want to look into building a service mesh to interconnect all these elements. And again, the service mesh, it will give you mutual TLS, it will give you observability between what's happening between the SMF and AMF. But also here, you may not have all the functions that you need in the solutions that are available. So we've been working with very large service providers, and they have asked us to include features like packet capture to provide lawful intercept purposes. Again, that's a way to enhance an IT solution to become more telco aware. I just want to zoom in into one example here of how to make an IT solution more telco aware, and that's the example of the service mesh. So if you look at the service mesh, it interconnects application microservices typically, and in this case it needs to interconnect different 5G microservices or 5G functions, if you will. So what the F5 Aspen Mesh solution does in this case, it injects these sidecar proxies, and they take care of the visibility, they take care of the mutual TLS encryption, and they offload the 5G functions from having to do this, right? Because this is stuff that needs to repeat it for every application anyway. So this is what they do. The problem here was that the normal, let's say, tracing or the open tracing that is available from the IT world and that we would use for application tracing is not really suitable for telco use cases. Telecom operators, they typically use probes in their network to get visibility into the traffic. But obviously, in a container infrastructure, you can't put a probe, right? There's no place to put a probe there. So what they wanted is they wanted the capability built in to the service mesh to give them an output that feeds into their systems that interconnects with probes on the 4G and the 3G side of the network as well. So what we did here is we inserted a tap function in the Aspen Mesh solution, which really gives you a full packet capture of all the traffic that goes between the AMF and the SMF in this case. And then we feed it into a node agent, which converts it into HTTP streams in PCAP format, which then allows them to leverage all the infrastructure they already have in their packet broker architecture. So again, just one simple example of how we can add certain capabilities to an IT-based solution and make it more telco aware. Now, 5G management plane, if you look at APIs in general, right, the telco API market is a growing market, and it's growing significantly. As you can see here, it's a report from Mordor Intelligence. They expect that market to grow with a CAGR of over 23% in the next 5 years, and that's a significant growth. And the telco API business already started on the OSS BSS side. So TM Forum, which is really specifying OSS BSS systems, they have been working on developing open APIs for interacting with third parties. And the reason they do it is because it creates a much more open architecture, and every telco has the same types of APIs, regardless of which vendor they have. All vendors are endorsing these APIs, and every telco can now interact with third parties using the same APIs, interconnecting with their OSS BSS systems. And already there, they embraced the Open API initiative, which is an initiative that comes from the IT industry. Now with 5G down the road and with the network exposure function, this is an element in the 5G network that's going to allow you to expose some capabilities of the 5G networks to third parties. So just like these TM Forum open APIs, you're now going to actually even give your business partners even more APIs to get some degree of control over your network. And we believe that is obviously going to create new business opportunities, and that's going to probably even fuel this telco API business even more. Now, telco APIs is obviously a mechanism to connect with external partners. And the more popular something gets and the more money people make on something, the more attractive it will become for hackers, right? So the message that we give to our customers is that, yes, you obviously need API gateways and API management, but let's make sure you also focus on having a very strong API security solution there. If you look at what F5 is doing in this business, obviously with the acquisition of NGINX, we now have an API management and an API gateway solution in-house that helps our customers to deliver these types of functions. And the NGINX solution is very much focused on microservices environments, modern environments, so it fits perfectly into that architecture. But also with our solutions on the big IP side of the house, with our application security functionalities, with our identity and access management security solution, we're also adding more and more API security features there. And obviously we are now bringing these two things together, making sure our customers have a very strong API management solution, but coupled with very strong API security capabilities, because security is going to be critical to protect these types of APIs. And here's just a quick example. I'm not going to spend too much time on it, but it is interesting to see how something that started many years ago in the IT industry is really getting embraced by the telco industry. First by TM Forum, obviously, but now also by 3GPP. So the Open API specifications for instance, the NRF API. This is an extract from a 3GPP spec. So this is not something that we would have expected to see in 3GPP specs a few years ago. So you really see IT technologies, IT initiatives finding their way into telco standardization bodies as well. And for us as a company coming from both sides of the fence, this is definitely a very interesting evolution for us. Last but not least, the 5G application plane. So this is really, let's say, I'm not going to go into much detail on this because this is not really going much into 5G. This is more about how do you manage and secure your applications in a private cloud, in a public cloud, but also now in this distributed telco cloud, right? As soon as you start moving applications into these environments, putting them in your edge locations where you have 5G functions and applications living side by side to each other, you will need these types of security functionalities in these environments. And as many of you know or may know, F5 has a fairly extensive set of security solutions. Our view is we are very application security centric, right? Every security solution that we come out with is always going to be really focused on how do I make the application more secure? Secure against attacks, secure against fraud, secure against DDoS attacks, et cetera, So I'm not going to go into any level of detail of these different solutions, but here you can see the different types of attacks and different types of mitigation techniques you need to fully protect an application. And given the fact that NGINX is part of the F5 family since more than a year now, we are working on infusing more and more of these security capabilities into the NGINX framework. So that makes it completely integrated into modern application architectures. And being integrated into modern application architectures is obviously very important also for our 5G story, because 5G is also about modern application architectures. The key point for us here is also, and we have the same view on 5G as we have on the application side, is that you try to decouple the functionalities from the underlying architecture. So we are multi-cloud and multi-platform capable. So whether you run your application and the security functions in front of that application in AWS, in Azure, in a VMware environment, which is a private cloud, in a Kubernetes environment, in an on-prem traditional environment, we want to make sure that you can leverage the same security capabilities across the board on any of these platforms. So you can quickly move and port these applications where you go. We believe for 5G that is equally important, and especially for edge computing, because it's a very it's very much a moving target at the moment, I would say. If you look at edge computing, this is a very crowded area where everybody is trying to grab a piece of the business. We see service providers launching parallel initiatives, like some initiatives where they are building their own edge compute stack. In another initiative, they partner with a company like AWS or Azure to help them build the stack. The thing is, it's very uncertain where this market is going. So if you decouple your functions from the underlying architecture, you know that you can easily move from one environment to the other. If you start relying on very specific security functions that are available in each of these cloud platforms, it will make it much harder for you to change from one environment to the next. So we believe it's a good practice to keep a clean decoupling between what we would call the infrastructure that's hosting all your functions, and then the functions that you run on top of it. So to summarize, going back to the original question, right, is 5G security, is it about IT security or is it about telco security? I hope that with the examples I gave you, it becomes clear that it's a bit of both. And we just need to get the best of both worlds, right? We just need to evolve some of our telco security solutions into virtual environments and containerized environments. And at the same time, as you saw in the control plane and the management plane, we actually have some available IT security solutions that with a little bit of extra capabilities are very well suited into these 5G environment. So you see that evolution coming from both sides, and I think ultimately this is going to bring the telco industry and the IT industry even closer together, and that's how we started this discussion in the first place. And then, of course, to reiterate the point I made on the previous slide, please make sure that whether it is F5, obviously we would like you to work with F5, but even if you pick different vendors, I think it's a very good strategy to keep your security functions completely separate from the underlying platforms that you're going to host your applications and your networking functions on. And with that, I reached the end of my presentation, and I'm going to pass back the word to Raffaele. Over to you, Raffaele.
Thank you very much, Bart. Yeah, just as a reminder for people that joined later, we are now the Q&A live session. We have the Q&A box, so you can post, let's say, your question in the Q&A box if you still have any, and we will answer them live. So we already have a few of them. So there was one asked in the very beginning of the presentation, which I assume has been in some way already answered, but maybe Bart, you want to add something. It's what's the main differences between 4G and 5G except for the higher speed?
Yeah, I think that probably somebody that joined a little bit later. What the big difference is, obviously, it's not just higher speed. I mean, in terms of functionality, if we just speak functionalities, it delivers a lot of things, right? Higher speed is just one of them, but also lower latency, which is important for some use cases. Also, the number of devices you can connect to 5G is going to be much more than what used to be possible in 4G and 3G. And then, of course, the architecture itself allows for things like network slicing, which really allows you to completely separate, or let's say allocate radio resources, core resources to specific use cases. That was not possible in 3G and 4G networks as well. And then the third thing, and that was one of the key points of my presentation, is really around the architecture, right? Instead of having dedicated, purpose-built platforms, you now move into an architecture which is based on microservices. Similar to a modern application, you have different microservices, each representing a 5G function. which talk over an API, which is HTTP2 based, again, very similar to what's happening with applications in the IT industry, and having a complete modern application architecture. So I think functionally as well as architecturally, 5G is a massive shift in how service providers are going to build and operate networks.
Thanks, Bart. Next question is, you didn't speak about automation of security policies. Is that something where we can also learn from the IT industry?
Yeah, very good point. And then, of course, this was, I was hesitating to add a slide on this, but then I thought, like, I'm not going to be able to finish in time. But yeah, let me cover that. It is absolutely true. If you look at the evolution, you see service providers moving from physical to virtual NFV, and now with 5G, they're going to go to the next step, which is Kubernetes, containerization, etc. We've also seen an evolution from using, let's say, telco provided NFV orchestrator platforms to some operators looking more into, let's say, open source tools which are used in the IT industry. And I would say there is room for both, but we definitely see more and more of our customers looking into tools like configuration tools like Ansible, like Terraform, to deploy and manage their different virtual functions, or in the future even container functions. And obviously as F5 as a company, that's again a very interesting thing to see for us, because from our IT side of the house, we have been working on modules for Ansible, we have been working for scripts for Terraform, so we have a lot of these things already available for our IT solutions. And given that we're using the same code base for our telco solutions, it is very easy for our customers to start using Ansible, Terraform for deploying virtualized big IPs in telco environments. But that is definitely a trend that we start to see. And you see telco people getting more and more into this IT stuff, more and more also looking into some open source tools like this. So yeah, I mean, we're definitely going to see that more and more. And again, for F5, this is a very interesting evolution.
Thank you, Bart. There is another question saying, would it be possible for you guys to have a short summary with 2-3 key values on how F5 can help SPs within 5G security?
Okay, that's that's a broad question. So what I try to do, and frankly, this is a bit the philosophy we have behind the My Forum sessions. We want to provide educational sessions. So we're not seeing this as a sales pitch. We just want to give you our viewpoints on how we look into the market from the F5 lens. But my goal of this presentation was not really to try and sell you any specific F5 product. Now, some of the things, of course, when you look at this, you can probably think like, okay, based on what he is saying, probably F5 is working on a couple of things in that direction. Some things we already have, some things are being developed as we speak. So in a forum like this, I can't really make very public statements around that. So my suggestion would be that, yeah, reach out to your local teams and we can get into a more deep dive discussion, because we definitely can talk a little bit deeper on some of these aspects.
Thank you, Bart. There is another question on the Open RAN. How do you see Open RAN in the US and the EU? Is it a trend that is getting bigger and bigger, or is it just a very specific use case technology? Obviously, Open RAN is not really something that we as F5 are very deeply involved in, because, and that's also the reason why I restricted myself to the data plane, control plane. I deliberately did not talk much or did not talk at all about the RAN aspects, or let's say I also didn't talk about authentication aspects of mobile phones, because those are areas we're not very involved in. I can just speak from my personal experience of what I see in the market here, and I think Open RAN is definitely getting more and more traction. It is a topic that we see popping up more and more, and I do get the feeling that some service providers, I cannot name them specifically, are getting more serious about it. So I think
Yeah, I can see the trend. Obviously, I'm not deeply involved in these discussions because F5 is not deeply involved in it, but I can only see that it pops up more and more. And I do get the feeling that people are becoming more and more serious about it. I don't know, Raffaele, I mean, you've been talking to a lot of service providers as well. If you have any additional viewpoints on that.
Yeah, I mean, this is for sure, let's say, a trend that we see more and more, let's say, interesting for service provider. There are several service providers that they publicly, let's say, share the interest in the Open RAN infrastructure. Hopefully, let's say it's a technology that is more more let's say focused on the radio side, on the pure radio side. But there are some trends that are going in both directions, both in the EU and the US. Yeah, that's definitely, let's say, the trend that I see as well. Okay, so the other question is, don't you think it would be interesting to use some anti-DDoS tool between the radio access network and the core, so like UBF or AMF, in order to avoid DDoS attack or signaling storm? What is your opinion?
Yeah, absolutely. And this is, that's also the interesting thing. If you look at the 5G standards, right, I think the 3GPP has defined much more security in the 5G specs than they ever did before. So that's one thing to start with. But obviously, because of the fact that this is such an open architecture, you will have to protect your traffic from many different angles. If you look historically, DDoS, the way people were doing DDoS historically is you would look at your pipe to the internet and you would protect incoming traffic there using NetFlow mechanisms and whatever have you. But the philosophy behind deploying DDoS was really around protecting traffic against evil attacks coming from the outside. That was like the basic principle of deploying DDoS in the early days. Now, because attacks have become so much more sophisticated, because service providers know that people are using IoT devices in their homes, which are not where people are not changing their passwords. They know that attacks can come from the inside as well, because the devices that are connected to their network are impacted and they don't have full control over them anyway. So the philosophy around DDoS is now changing drastically, in the sense that you now need to protect yourself not only against attacks from the outside, but also from the inside. And to the point of the question, like, do you not need to protect from the RAN to the core? Then the answer is obviously yes. So what we do with this solution with the SmartNIC is, obviously with this solution you can sit in line for traffic coming from anywhere, right? And then specifically for control plane elements like the 5G core, that is definitely an area where you want to have full inline DDoS protection, going all the way from volumetric, which is mitigated by the SmartNIC, all the way into application level DDoS, going deeper into the protocols. So yeah, I would say the directional aspect of DDoS is gone now. It's a zero trust architecture, right? No matter where traffic comes from the RAN, from the core, from the internet, nothing can be trusted anymore. And that's where I think this SmartNIC solution is going to be very, very important going forward, because people will want to have more and more inline DDoS capabilities.
Yeah, and to be added on it, obviously the 5G bandwidth is also let's say, making as a requirement the fact that we have to use hardware acceleration. Okay, Bart, the next question is, in 5G we will have many VNFs and CNF with many components. According to you, what is the best strategy for certificate management and maintain confidentiality and trust between the different VNF components, or CNF components, as they refer to CNF as well?
Yeah, I mean, specifically for the CNF components, that is a function that can be provided by the service mesh. Service mesh typically does that, because the way the function of a service mesh is like, people started building applications in microservices, and then you started creating APIs between them. And that's how it all started, right? And then at some point, people started to realize, like, hey, I mean, these microservices could sit in different nodes, and I want confidentiality and encryption. So I need to have encryption between them. And that's basically how Service Mesh started, right? So instead of having the application developer write all this code, why don't we offload it to a separate component? And that is this so-called sidecar proxy, which gets injected in the application pod. So they're responsible for this mutual TLS authentication. So it's bidirectional mutual TLS authentication and encryption. And the certificate management is actually done by the control plane of the Service Mesh. The Service Mesh has a control plane, and it manages all these reverse proxies, these sidecar proxies in these different things. So on the Service Mesh, I would say that is completely managed by that aspect.
Yeah, and to be added on that, I mean, even the service meshes are evolving towards a model that is going to include also functions that are not containerized. So as Bart said, the service mesh is going to be solved on the CNF, but there are understudy also models that are involving, let's say, the virtual function as well. So most likely the problem will be solved in the same way with the same kind of approach. The next questions, I'm trying to go through all of them because they're coming through. So if we partner with a public cloud provider for our edge compute strategy, wouldn't it be easier to use their security tool to secure our network and our applications?
Yeah, okay, that brings me back to the point I made in, I think it was the last slide, right? Wouldn't it be easier? Yes. I think it will. I mean, because usually these cloud providers, they try to bake security functions into their platform and make them easy to consume. I mean, these cloud platforms are built to make it as easy as possible for you. The question obviously is like, okay, are you gonna, if you put your security functions in that architecture, the first question is like, do they offer all the capabilities, right? I mean, typically this is not their core business. Their core business is really to host your applications and give you a framework to do that. But security is typically not their main area of focus. For us as a company and for some other companies, that is more the case. So that's the first question, like, do they deliver all the security functions that you need to provide that level of protection that you expect? Second, and that's because I was saying with edge computing, it's such a jungle right now with so many different vendors all trying to grab a piece of that market. I think if you look at, you have public cloud providers getting there, you have private cloud platform vendors getting into it, you have small startups coming up with new innovative ideas on how to architect edge compute environments and how to federate different edge compute sites with other service providers. There's a lot of activity there. And the reason there's a lot of activity is because people see that this is the future, right? I mean, an Amazon and an Azure, they also know that not all applications are going to live in a centralized cloud. Many of them will actually move there. So it's a very competitive area. And therefore, we see service providers betting on several horses, right? I see service providers having their own teams working on something, and in parallel, they announce a partnership with AWS and Azure for speed to market, getting faster to the market. But it means that they haven't really decided yet in terms of which way to go, and we're trying out different things. So decoupling your security functions from that underlying platform is not going to lock you into anything. It's when you move your functions, you move your security functions with it, and you get to enjoy the same security functions in an AWS, in your private environment, in a VMware environment. You will always get the same security function. And I think those are the key points. Having that portability, because it's a little bit uncertain where the market is going, and having consistency, so you can really standardize on what type of security functionality you want for every part of your architecture.
Thanks, Bart. I think we still have 1 minute for one last question, which is what, let's say, F5 product feature can be used to help, let's say, within within 5G security. So this is in some way related to the previous one, but maybe you want to add a little bit more on top of it.
Yeah, obviously, What we have in the portfolio, obviously the GI LAN solution, which I covered in a little bit of depth. I mean, that's a solution that is publicly available. We have a virtual solution. We have a VNF manager that allows you to easily deploy this at large scale. And obviously, this is a solution that we will continue to evolve to fit into a 5G architecture and to fit into from a GI LAN to an N6 architecture. So that is definitely a direction that we're going into. From the infrastructure components, there's a couple of things that you've seen there in terms of what we do on what we could do on Kubernetes Ingress, on the service mesh, on the API side. Some of these things are actually work in progress. We are working with some large service providers on some of these solutions already. And then on the API management gateway side, I think I briefly touched upon the topic that with NGINX we have an API management and gateway solution already. With our AWAF and our APM products, for those familiar with the 5 big IP terminology, we have very strong security components that are extended to include some API security capability. So we're now bringing these things together and give our customers a very strong API gateway / security solution. So yeah, I mean, some of these things are work in progress. Some of these things are already available, but yeah, we're very happy to engage and make sure that whatever steps we take are fully in line with the needs of our customers.
Yeah, and as you were mentioning before, obviously, guys, contact your sales representative if you want to have more details on this, because they can give you all the details that you need. There are still questions coming, but yeah, unfortunately, we don't have more time, so our time is gone. So for the people that didn't get any question answered, again, we encourage you to contact your local sales representatives. So with that, yeah, we conclude this F5 webinar. Yeah, we'd like to thank you for joining us, and obviously like to thank Bart for presenting the 5G content today. Obviously look at your emails, because you will receive a pointing to the recording of this session, because this session is recorded. And yeah, as final note, we look forward to hosting you on our F5 webinars, the future one, and we'll remind you to visit the F5 My Forum webpage. You will find them both the recording and the live webinars, like the one that Bart was mentioning during his presentation as well. So thanks again for being with us today, and stay safe and stay healthy. Thank you.
Thank you very much.